In 1965, on the assembly lines of Milwaukee, Wisconsin, Harley-Davidson killed the most famous engine it had ever built. The introduction of the Electra Glide was a commercial triumph. It brought a 12-volt electrical system, a heavy electric starter, and a massive 800-pound touring frame to the American highway. But that same luxury pushed the aging 74 cubic inch Panhead engine past its thermal and mechanical limits. By 1966, the factory discarded the Panhead architecture for the new shovel head. The factory line moved on. The touring riders upgraded. The old aluminum heads were left behind in dealership scrap bins across the country. But the engine did not die. The very machine that failed under the crushing weight of factory touring was about to become the immortal, stripped-down heart of the American chopper. The real story of the Panhead 74 is not only the story of an engine that failed to pull a heavy touring bike. It is the story of how an obsolete piece of Milwaukee iron was chopped up and rebuilt into the defining symbol of the open road. Every week, we tell the stories of the motorcycles, engines, factories, dealerships, and roads that once carried American industry, and what happened when the market moved on. Subscribe if that history matters to you. The story begins not with nostalgia, but with a specific place in Milwaukee, Wisconsin, in 1948. In 1948, the American highway was changing. Hundreds of thousands of veterans had returned from the Second World War with a new understanding of mechanical power and a desire to travel across a country that was rapidly expanding its paved road network. The American motorcycle market was shifting from local utility to cross-country touring. Riders did not just want a machine to get to the factory, they wanted a machine that could cross state lines at sustained speeds. At its headquarters in Milwaukee, Wisconsin, Harley-Davidson faced an engineering problem. The company's flagship engine, the 74 cubic inch knucklehead, was legendary, but it belonged to an older world of riding. The knucklehead, an overhead valve engine where the valves sat in the cylinder head rather than the engine block, had established Harley-Davidson's reputation for power when it was introduced in the 1930s. A V-twin engine, two cylinders arranged in a V-shape sharing a single crankshaft, gave an American motorcycle the low-speed torque necessary to pull a heavy frame away from a city curb without stalling. But the knucklehead was made entirely of cast iron. Cast iron held heat. As American highways grew longer and average speeds increased, the old engine architecture began to suffer. A rider holding the throttle open across the Texas Panhandle would watch the engine run dangerously hot. Furthermore, the knucklehead was notorious for leaking oil from its upper end, and its solid valve lifters required constant, precise adjustment by a mechanic using feeler gauges to maintain proper clearances. Milwaukee needed a new architecture, a machine that could handle the sustained heat of highway touring while reducing the maintenance burden on the rider. In the spring of 1948, Harley-Davidson pushed a new motorcycle onto its dealership floors, the FL Series. Powered by an engine the public would quickly name the Panhead, due to the smooth, cake pan-like chrome covers sitting on top of the cylinders. The defining engineering shift of the Panhead was not just a visual change, it was a material one. Harley-Davidson replaced the knucklehead's heavy cast-iron cylinder heads with aluminum heads. Aluminum dissipates heat far faster than cast iron. In a practical American context, this meant a rider crossing the Mojave Desert in July could maintain a steady highway speed without the engine's top end cooking its own oil, warping its components, and losing power. But the aluminum heads were only half of the 1948 equation. The engineering team in Milwaukee also introduced hydraulic valve lifters. A hydraulic valve lifter, a small mechanical cylinder that uses pressurized engine oil to automatically take up the slack in the valve train, was a revolution for the touring rider. Before 1948, an American rider crossing the country on a heavy V-twin had to carry tools, pull over at regular intervals, wait for the exhaust pipes to cool, and manually adjust the valve clearances. If they failed to do this, the engine would lose compression, run poorly, or destroy its own valve train. The hydraulic lifter promised to end that roadside ritual. In a rural dealership in Ohio, a salesman could look a customer in the eye and promise an engine that adjusted its own valves as it ran, using nothing but the pressure of its internal oil pump. The 74 cubic inch displacement, roughly 1/200 cubic centimeters, was a massive volume for a motorcycle of that era. When the 1948 FL models rolled into showrooms with a retail price hovering around $650, they represented a significant capital investment for the American worker. But the Harley-Davidson dealer network, spread across hundreds of main streets and rural crossroads, understood how to sell that investment. They sold the Panhead not as a weekend toy, but as a primary vehicle, a heavy piece of industrial equipment that could be financed, serviced, and relied upon to bridge the vast distances between American cities. Dealerships reported strong demand from riders who wanted a machine that required less roadside wrenching and offered more time in the saddle. The 1948 Panhead still utilized a rigid frame, a chassis with no rear suspension, where the rear axle was bolted directly to the metal tubing. The only shock absorption came from a sprung saddle and the pneumatic bounce of thick rubber tires. Yet, despite the punishing ride quality of the rigid frame, the engine itself proved that Milwaukee understood where the market was heading. The machine ran cleaner, leaked significantly less oil than its predecessor, and stayed much cooler under heavy touring loads. It was an industrial triumph that solidified Harley-Davidson's grip on the heavy cruiser market, fending off early threats from lighter, faster British imports that were beginning to land on the east and west coasts. However, the engineering that made the Panhead a marvel in 1948 also introduced a new kind of vulnerability into the American garage. The hydraulic valve lifters relied entirely on a steady supply of clean, pressurized engine oil. In an era where oil filtration on motorcycles was still rudimentary, and many riders still used straight-weight, non-detergent oils that left thick sludge in the crankcase, the tiny oil passages feeding those lifters could easily clog. When they clogged, the lifter would collapse, the valve train would hammer itself, and the quiet, low-maintenance touring engine would sound like a bucket of loose bolts. The engine demanded a level of fluid maintenance that the American rider was only just beginning to learn. Despite the early learning curve with oil maintenance, the 74 cubic inch V-twin had proven its thermal superiority. The factory had solved the heat problem of the cast iron era, delivering a powertrain that could run all day under a heavy load. The engine was ready for the new American highway. Now it just needed a chassis that would not punish the rider for crossing it. The 1948 Panhead engine solved the thermal crisis of the American heavy cruiser. But an engine cannot cross a continent without a chassis. The rigid frame of the late 1940s, paired with Harley-Davidson's traditional Springer front end, a heavy mechanical assembly of exposed springs and pivoting metal links, punished the rider over long distances. The Panhead had the torque to ride from Chicago to Los Angeles, but the suspension transferred every violent impact of the road directly into the rider's wrists and spine. If Harley-Davidson wanted to truly dominate the post-war touring market, the 74 cubic inch V-twin needed a breakthrough in how it connected to the pavement. In 1949, 1 year after the Panhead's debut, that breakthrough arrived in the form of the Hydra Glide. The Hydra Glide was Harley-Davidson's introduction of the hydraulic telescopic fork, a front suspension system using sliding metal tubes filled with hydraulic oil and internal springs to absorb impact. The technical explanation was simple fluid dynamics, but in an American riding context, it was a revelation. When a rider hit a deep pothole on a deteriorating Midwestern highway, the front wheel drove the lower fork tube upward. Instead of a violent mechanical crash of metal on metal, the hydraulic fluid inside the fork was forced through small valves, slowing the impact and dampening the rebound. The front wheel stayed planted. The rider stayed in control. Combined with the thermal efficiency of the aluminum cylinder heads and the low-maintenance promise of the hydraulic valve lifters, the Hydra Glide chassis turned the Panhead 74 into an industrial locomotive. It was no longer just a motorcycle. It was a heavy transport system. This transformation became immediately visible in the most demanding proving ground in the country: American police fleets. By the early 1950s, law enforcement agencies were undergoing a modernization of their own. Departments like the California Highway Patrol and the Chicago Police Department were expanding their motor units to police the rapidly growing suburban sprawl and the new high-speed interstates. But these departments required their motorcycles to carry new, heavy equipment. A police motorcycle in the 1950s had to carry a mechanical siren, heavy steel pursuit lights, a larger heavy-duty battery, thick steel crash bars, and most importantly, a two-way radio. A police radio in this era was not a small digital device. It was a massive, fragile box of glass vacuum tubes bolted to a heavy steel rack over the rear fender. The weight of a fully equipped police motorcycle was staggering, often approaching 700 pounds before a heavily geared officer even climbed into the saddle. Furthermore, many northern municipalities required the motorcycle to pull a sidecar, a single-wheeled passenger car attached to the side of the motorcycle frame, for winter patrols and traffic enforcement. This is where the Panhead's massive displacement created an impenetrable moat around Harley-Davidson. A British import like the Triumph Thunderbird was arriving on American shores during this same period. The British machines were powered by parallel twin engines, a two-cylinder engine with both cylinders standing side by side. They were agile, fast, and culturally exciting. But a 650cc British parallel twin was not designed to pull a heavy steel sidecar, a vacuum tube radio, and a 200-pound police officer up a steep grade in San Francisco traffic. The Panhead was. The 74 cubic inch V-twin produced massive low-end torque. The twisting force produced by the engine felt as the pulling strength necessary to move heavy weight from a dead stop. A police officer riding a Panhead did not have to rev the engine to high RPMs and slip the clutch to get moving. They simply rolled on the throttle, and the heavy flywheel carried the momentum forward. The engine pulled like a tractor, and because the aluminum heads dissipated the heat of slow-speed parade duty or idling at a traffic blockade, the Panhead could survive the brutal, low-airflow environment of municipal police work without seizing. This municipal dominance translated directly into dealership power. The Harley-Davidson dealer network understood that a police contract was not just a badge of honor. It was a guaranteed revenue stream. When a city like Milwaukee or Los Angeles purchased a fleet of Panheads, the local dealership secured the contract for parts supply, scheduled maintenance, and warranty repair. A dealership's service department, the back room where mechanics turned wrenches and ordered factory parts, could stay financially stable through the winter on police maintenance contracts alone. More importantly, the police fleet served as rolling public proof. When a factory worker or a returning veteran walked into a rural dealership in Ohio, the salesman did not have to explain the thermodynamics of an aluminum cylinder head. He only had to point out the window to the local highway patrolman idling at a red light. If the machine was durable enough to idle through a riot, carry a heavy radio across the desert, and pull a sidecar through a blizzard, it was durable enough for a civilian rider's weekend tour. By 1955, the Panhead engine and the Hydra Glide chassis had effectively standardized the American heavy cruiser. Harley-Davidson had created a machine that defined what the country expected a motorcycle to look like, sound like, and feel like. The wide handlebars, the deep fenders, the massive engine block, and the steady, uneven rhythm of the V-twin exhaust became the soundtrack of the open road. The engine had found its perfect application. It was strong, thermally stable, and backed by a nationwide network of parts counters and trained mechanics. The factory was operating at a scale that left domestic rivals in the dust and kept foreign imports relegated to the lightweight sporting categories. By the mid-1950s, the 74 cubic inch V-twin had conquered the police fleets and the open road. But the American rider was about to ask it to carry something it was never designed to hold: modern comfort. By the mid-1950s, the American highway system was undergoing the largest expansion in its history. The Federal Aid Highway Act of 1956 authorized the construction of the interstate highway system, laying down thousands of miles of high-speed, multi-lane concrete. The geography of American motorcycling shifted. A ride from Chicago to St. Louis was no longer a punishing, multi-day endurance test over rutted two-lane roads. It was a sustained, high-speed run. Harley-Davidson had the engine to conquer these new distances in the 74 cubic inch Panhead, and they had the front suspension in the Hydra Glide. But as the roads became longer and the riders grew older, the punishing reality of the rigid frame, where every impact from the rear wheel transferred directly into the rider's spine, could no longer be ignored. In 1958, the factory in Milwaukee introduced the next evolution of the FL series, the Duo Glide. The Duo Glide brought rear suspension to the heavy American cruiser. Milwaukee engineers equipped the motorcycle with a swing arm, a pivoting metal cradle holding the rear wheel, controlled by twin coil-over shock absorbers. A shock absorber, a hydraulic dampening cylinder surrounded by a heavy steel spring, allowed the rear wheel to travel vertically over bumps while keeping the chassis stable. With hydraulic suspension at both the front and the rear, the motorcycle was no longer just a piece of rolling agricultural equipment. It was a luxury vehicle. This mechanical shift fundamentally changed the dealership showroom. When a customer walked into a Harley-Davidson dealership in 1959, they were not just looking at a bare motorcycle. They were looking at an entire ecosystem of bolt-on touring accessories. The Panhead engine was now expected to pull a heavy, clear, acrylic windshield to block the highway wind. It was expected to carry fiberglass saddlebags, hard-sided, weatherproof luggage compartments mounted to the rear frame, allowing riders to carry a week's worth of clothing. It carried heavy chrome crash bars, a massive, sprung buddy seat for a passenger, and thick, white wall tires. Harley-Davidson packaged these accessories into what became known as the King of the Highway group. A fully dressed Duo Glide became a rolling showcase of American industrial pride, gleaming with chrome and thick enamel paint. In a post-war America where the highway represented ultimate mobility, the heavy touring motorcycle did not merely represent leisure. It represented an industrial promise that a rider could cross state lines with the same mechanical confidence, protection, and comfort as an automobile. If this machine failed, Harley-Davidson would not simply lose a model. It would lose its claim to the American highway, surrendering the touring market entirely to the enclosed car. The 74 cubic inch V-twin responded beautifully to this new, affluent era. The low-end torque easily handled the added weight of the suspension components and fiberglass luggage. On Route 66, strings of Duo Glides could be seen cruising at sustained speeds of 65 miles per hour, their aluminum cylinder heads dissipating the heat, their hydraulic valve lifters operating quietly under the chrome pan covers. The police fleets continued to place massive orders, knowing the new rear suspension would reduce officer fatigue during long shifts. The Panhead had achieved total mechanical and cultural dominance in the heavy cruiser category. It was the undisputed king of the American road. But a motorcycle is not just defined by what the factory builds. It is defined by what happens to the older models when they hit the used market. As affluent riders traded in their older, rigid-frame Panheads from the late 1940s and early 1950s to finance the new Duo Glides, a massive secondary market was born. These older motorcycles, mechanically sound but lacking the modern comfort of rear suspension, ended up in the back corners of independent repair shops, salvage yards, and small-town classified ads, selling for a fraction of their original price. This created a profound physical divide in American motorcycle culture, one centered entirely around the Panhead engine. On the dealership floors, the engine was being dressed in hundreds of pounds of chrome and fiberglass, but in the back alley garages, it was about to be stripped down to its bare iron and aluminum. As the 1950s gave way to the 1960s, a younger generation of riders, many of them returning from the Korean War or working in the expanding aerospace and manufacturing sectors of Southern California, looked at the heavy, chrome-laden duo glides and saw a machine burdened by excess. They did not want a two-wheeled luxury vehicle. They wanted pure, unadulterated acceleration and a machine that reflected their own mechanical independence. They turned to the used market. A rigid frame Panhead from 1948 or 1950, traded in by an older touring rider for a new duo glide, could be bought cheaply. In small, independent garages across California, Texas, and the Midwest, a new American motorcycle industry was being born with hacksaws, welding torches, and a total disregard for factory specifications. These riders began to strip the Panhead down to its absolute mechanical minimum. They removed the heavy fiberglass saddlebags. They unbolted the massive steel fenders and threw them into the scrap pile. They removed the thick, sprung buddy seats and replaced them with minimal leather pads. They discarded the massive factory fuel tanks in favor of small, low-capacity peanut tanks to expose the rocker covers of the V-twin engine. They took off the heavy front brake drum, a modification that spoke entirely to aesthetics and the desire to shed weight over factory safety. This process of bobbing, or chopping, the motorcycle, transformed the heavy touring machine into a skeletal, aggressive street brawler. The Panhead engine was the perfect canvas for this new American custom culture. Stripped of the 800-pound touring load, the 74-cubic-inch V-twin was violently fast. The aluminum cylinder heads, freed from the aerodynamic drag of massive windshields and leg fairings, ran incredibly cool. The mechanical simplicity of the engine meant a rider with basic hand tools could rebuild a carburetor, swap a camshaft, or tune the hydraulic lifters in a home garage. This street-level obsession birthed a massive aftermarket parts industry. Small machine shops began manufacturing custom exhaust pipes, extended front forks, and modified frames specifically for the Panhead architecture. Authorized Harley-Davidson dealerships often refused to service these heavily modified machines, driving the chopped Panheads away from the official service bays and into a thriving underground network of independent repair shops. This era represented the absolute cultural peak of the Panhead. It existed simultaneously in two completely different American worlds. On the pristine dealership floors, it was the beating heart of the ultimate luxury touring machine, trusted by highway patrols and affluent cross-country travelers. In the back alleys, swap meets, and local drag strips, it was the defining engine of the American chopper, a symbol of mechanical rebellion that would soon be immortalized in American cinema and magazine spreads. If this engine failed, America would not simply lose another motorcycle brand. It would lose a system of machining, repair, dealer trust, and road culture built around that machine. But the engineering math was beginning to turn against Milwaukee. The factory was listening strictly to the touring customer, and the touring customer wanted more comfort, more electrical accessories, and more weight. Every year, the FL series grew heavier. The engine block, originally designed in 1948 to push a relatively stripped-down, rigid frame, was now being asked to pull nearly a half-ton of steel, fiberglass, rider, and luggage at sustained interstate speeds. The factory was building a two-wheeled Cadillac, but beneath the chrome, the windshields, and the fiberglass saddlebags, the 1948 engine block was suffocating. The collapse of an American engine empire rarely begins with a massive factory shutdown or a sudden bankruptcy. It begins with a quiet frustration at a rural dealership parts counter. For the Panhead 74, the first small crack in the foundation appeared not in the fundamental geometry of the engine itself, but in the maintenance habits of the American rider. Harley-Davidson had introduced hydraulic valve lifters in 1948 to eliminate the need for constant, side-of-the-road mechanical adjustments. But a hydraulic lifter requires a steady supply of clean, highly pressurized engine oil to function properly. In the 1950s and early 1960s, many American riders and independent mechanics were still using straight-weight, non-detergent motor oil. Non-detergent oil does not suspend dirt and carbon in the fluid. Instead, it allows thick, heavy sludge to settle in the bottom of the engine crankcase. When a rider pushed a heavily loaded duo glide across a hot Nevada highway, that sludge would circulate. The microscopic oil passages feeding the hydraulic lifters would quickly clog. When a hydraulic lifter starves for oil, it collapses. The precise mechanical tolerance in the valve train vanishes instantly. Suddenly, a rider cruising at 60 miles per hour would hear a violent, rhythmic hammering coming from the cylinders. The engine would lose compression and power, forcing the heavy motorcycle onto the shoulder of the road. To fix it, a mechanic had to tear down the top end of the engine. In many independent repair shops, mechanics grew so frustrated with this hydraulic failure that they simply threw the factory components into the scrap bin and installed older, solid lifters. They returned the engine to the exact roadside maintenance ritual Milwaukee had tried to eliminate. The second crack appeared in the engine's defining feature, the aluminum cylinder heads. Aluminum was a brilliant engineering choice for dissipating the heat of a massive V-twin, but aluminum is a soft metal, highly susceptible to heat cycling and mechanical stress. As these motorcycles aged and entered the secondary market, they often fell into the hands of local mechanics who did not use torque wrenches, precision tools that measure exactly how much twisting force is applied to a fastener. If a mechanic tightened the cylinder head bolts unevenly, or if the engine was pushed too hard while pulling a heavy police sidecar up a steep grade, the aluminum head would physically warp. Once the head warped, the delicate seal between the iron cylinder and the aluminum head was broken. The engine would develop a severe intake leak, sucking excess air into the combustion chamber. This caused the engine to run dangerously lean and incredibly hot, eventually melting a hole directly through the top of the aluminum piston. A machine built to conquer the American highway was frequently returning to dealership service bays on the back of a tow truck. These mechanical flaws were compounded by a massive shift in the American riding environment. This was the arrival of Force 4, cars, highways, regulation, insurance, and changing rider habits. In 1948, the Panhead block had been designed to push a relatively stripped-down, 500-pound rigid-frame motorcycle across two-lane roads at 50 miles per hour. By the early 1960s, the interstate highway system was demanding sustained, uninterrupted speeds of 70 miles per hour. Furthermore, the American touring rider now expected the comfort of a convertible automobile. They demanded full hydraulic suspension, massive acrylic windshields, heavy fiberglass saddlebags, and thick steel crash bars. The weight of a fully dressed Harley-Davidson FL model had ballooned to nearly 800 pounds. The 1948 engine architecture was suffocating under this modern load. It was constantly operating at the absolute limit of its thermal and mechanical capacity. In a police motor unit in Los Angeles, an officer tasked with high-speed freeway pursuit found that the heavy Panhead simply did not have the top-end horsepower to chase down modern V8 automobiles. The low-end torque was still present, but the engine ran out of breath exactly when the new highways demanded more speed. This created a severe crisis defined by Force 1, manufacturing, engines, labor, and supply chain costs. Harley-Davidson was trapped by its own factory tooling. To completely redesign the Panhead engine with larger cooling fins, thicker cylinder walls, and stronger bottom-end bearings would require tearing up the assembly lines in Milwaukee and investing millions of dollars in new casting molds and machining equipment. The company, facing tightening budgets and increasing competition from lighter, faster, and cheaper British imports like Triumph and BSA, could not afford a total engine redesign. Instead, the factory engineering team tried to band-aid the aging architecture. They reinforced internal bearings, tweaked the oiling system, and issued service bulletins advising dealers on better maintenance practices. But the fundamental geometry of the 74 cubic inch V-twin remained unchanged. The Panhead was a prisoner of its own early success, forced to drag the massive, chrome-laden weight of American touring culture into a decade it was never designed to see. The engine could still run, the dealer network still pushed the heavy cruisers out the showroom doors, but the mechanical margin for error had completely vanished. The heat was building. The factory was building heavier motorcycles for a market that refused to give up a single pound of comfort. The architecture was already pushed to its absolute breaking point, and then in 1965 the factory decided to add the one component the American touring market demanded most, setting the stage for the engine's final collapse. The final collapse of the Panhead at the factory level arrived not because the engine was inherently weak, but because of a direct collision between Force 1, manufacturing limits, and Force 4, changing rider habits. In 1965, the American touring rider demanded the one luxury feature the Panhead was never meant to accommodate: the electric starter. An electric starter, an electric motor that turns the engine when the rider presses a button, fundamentally changed the dealership showroom demonstration. A customer no longer had to balance an 800-pound motorcycle on one leg, while violently kicking a heavy lever to bring the engine to life. Harley-Davidson bolted the starter onto the newly named Electra Glide, cementing the machine as the ultimate American luxury cruiser. But an electric starter requires massive electrical power. It necessitated a heavy 12-volt battery, thick copper wiring, and a vastly widened primary drive housing to cover the new starting gears. The motorcycle gained even more weight. Worse, the large battery box and the expanded primary case restricted the ambient airflow around the rear cylinder. The 1948 aluminum cylinder heads were completely overwhelmed. The engine was essentially baking itself inside a heavy shell of fiberglass luggage, steel crash bars, and electrical accessories. The warranty claims piled up at dealership service counters. Mechanics were tearing down burnt, warped top ends on brand-new motorcycles. The engineering team in Milwaukee realized that no amount of internal tweaking could save the Panhead. It needed a deeper, structural redesign. It needed different intake porting, stronger rocker arms, and a new combustion chamber shape to survive the heat of a 12-volt electric start touring reality. In 1966, just 1 year after introducing the Electra Glide, Harley-Davidson killed the Panhead. They replaced the smooth aluminum pan covers with the heavier, differently shaped alloy heads of the shovelhead engine. After 18 years of American highway dominance, the 74 cubic inch Panhead was permanently erased from the factory catalog. But the collapse of the Panhead at the factory was exactly what the street needed. As affluent touring riders flocked to dealerships to trade in their aging, kickstart Panheads for the new electric start shovelheads, the secondary market flooded with unwanted iron. A used Panhead engine, especially one bolted to a rigid frame from the late 1940s or early 1950s, became incredibly cheap. Dealerships practically gave them away to clear showroom space. In small independent repair shops, backyard garages, and custom fabrication bays from Los Angeles to New York, the Panhead was unbolted from its touring identity. Young builders stripped away the acrylic windshields, the heavy fenders, the police radios, and the hydraulic suspension. They took a machine that Milwaukee had desperately tried to modernize and forcibly dragged it backward into raw mechanical aggression. This was the birth of the American chopper age. The Panhead was the perfect platform. Without the crushing weight of the touring accessories, the engine ran cool and produced terrifying acceleration. Mechanics learned to rake the frame, cutting and re-welding the steering neck to extend the front fork, giving the motorcycle its iconic, stretched-out profile. They discarded the heavy front drum brake, a brake using shoes that press outward against the inside of a rotating drum. Valuing the clean, uncluttered aesthetic of a narrow-spoked wheel over stopping power. When a rider chopped a panhead, they could no longer take it to a franchised Harley-Davidson dealership for maintenance. Factory mechanics were often instructed not to service heavily modified frames or raked front ends due to liability and corporate policy. This exclusion created an entirely new American motorcycle industry, the independent custom shop. Parts counters that had nothing to do with Milwaukee began printing their own catalogs. Small-town machinists fired up their lathes to cut custom aluminum forward controls. Welders built custom steel sissy bars and upswept exhaust pipes. The 74 cubic inch V-twin was no longer just an engine. It was a standardized mounting point. An entire shadow economy of parts suppliers grew to support it. A rider could build a complete motorcycle around a panhead engine using parts ordered entirely from the back pages of custom motorcycle magazines. The very engine that the factory had discarded as thermally unstable became the absolute standard of mechanical rebellion. It powered the machines in low-budget motorcycle films. It defined the visual shorthand for the outlaw open road. The engine proved that a machine could outlive its manufacturer's intent if the local machining and repair culture decided it was worth keeping alive. The factory had tried to bury it. The street resurrected it. The factory line stopped. The catalog changed. The touring riders upgraded. The 12-volt system took over. The dealership scrap bins filled. The iron was stripped down. The frame was cut. The engine remained. The chopper era had just begun. When Harley-Davidson halted production of the Panhead in 1965, the factory assumed the engine would follow the natural life cycle of all obsolete industrial machinery. It was supposed to slowly disappear into salvage yards, replaced entirely by the electric start shovel head and the heavy touring frames of the modern era. But a strange industrial inversion occurred. The factory's decision to abandon the 74 cubic inch engine was the exact catalyst that made it immortal. The Panhead did not simply survive in the hands of a few dedicated collectors. It became the foundational architecture for an entirely new American industry, the custom motorcycle aftermarket. The aftermarket, the network of independent manufacturers, machine shops, and parts suppliers that build components outside of the original factory, was essentially born to keep the Panhead alive, and then to make it faster. When the original hydraulic valve lifters failed, independent companies engineered better, more reliable replacements. When the factory aluminum cylinder heads warped or cracked, independent foundries began casting stronger, thicker heads with better airflow. When riders wanted more horsepower, aftermarket machinists introduced stroker kits, modified crankshaft components that increased the engine displacement far beyond the original 74 cubic inches, turning the old touring motor into a devastatingly fast drag racing machine. This engineering rebellion reached its peak with independent American manufacturers like S&S Cycle in Wisconsin. These companies did not just build replacement parts, they began casting their own heavy-duty engine cases, the main lower housing that holds the crankshaft and oiling system. They solved the thermal and structural weaknesses that Harley-Davidson could not afford to fix in the 1960s. Because of this independent manufacturing network, the Panhead passes the ultimate test of mechanical relevance. This is not nostalgia. It is a surviving industrial reality. Today, an American rider can open an aftermarket catalog, order a set of aluminum cylinder heads, a reinforced engine case, upgraded internal bearings, and a modern carburetor, and assemble a complete zero-mile Panhead engine on a garage workbench. They can bolt that engine into a brand new rigid frame and ride a motorcycle that looks, sounds, and pulls exactly like a 1960s custom, containing absolutely zero original parts manufactured by Harley-Davidson. The 1948 engine architecture outgrew the company that created it and became an open-source platform for American mechanical expression. But the original Milwaukee iron still holds a sacred place in American motorcycle preservation. At massive vintage swap meets, outdoor markets where collectors buy, sell, and trade rare motorcycle components, original Panhead parts are hunted with intense devotion. At events like the Antique Motorcycle Club of America gathering in Davenport, Iowa, a set of pristine, uncracked factory aluminum cylinder heads or an original set of chrome pan covers can change hands for thousands of dollars. In this preservation culture, the engine exists in two completely different historical timelines. In the restoration community, builders spend years tracking down original factory bolts, correct leather saddles, and period-correct paint codes to rebuild the massive, fully dressed police motorcycles and Hydra glides of the 1950s. These pristine machines sit on museum floors and at high-end auctions, representing the peak of post-war American industrial optimism. They are monuments to a time when a motorcycle was built to conquer a continent in comfort. But the true legacy of the Panhead does not live behind museum glass. It lives in the independent repair shops and residential garages where the chopper ethos never died. It lives in the hands of a younger generation of builders who are still cutting frames, deleting front brakes, and stripping away excess weight, repeating the exact mechanical rebellion that started in California in the 1960s. Harley-Davidson built the Panhead to be a dependable, heavy-duty touring engine for a rapidly expanding highway system. It succeeded brilliantly until the sheer weight of American luxury and the demand for electrical convenience pushed the 1948 design past its breaking point. The factory abandoned it because it could not carry the future of the touring market, but the streets saved it precisely because it was the perfect machine for a raw, stripped-down reality. Somewhere in a dimly lit California garage, the air smells of rich gasoline and heavy motor oil. A rider steps down hard on a steel Kickstarter pedal. The 74 cubic inch aluminum V-twin coughs, catches, and settles into the violent, uneven rhythm that a factory once tried to silence, waiting to pull a rigid frame back onto the open road.